I'm Mike Parker. I have the Symmetrics BMT, which is a business management team, and I want to talk today about the VMAXe. The VMAXe is our largest product, and it goes up to 2,400 drives and a lot of cabinets, and that's what you use for the projects that are going to scale up large in the extreme, or could scale up large in the extreme. We realized after a while that there were some smaller, high-end requirements. Now, high-end requirements, again, the rules still hold true. A high-end requirement is a situation in which, if it fails, there's either loss of revenue, there's a financial loss, or in some cases there's literally a direct threat to life. VMAXe is a smaller implementation of the VMAXe. So in other words, this would be used for smaller hospitals or smaller banks or smaller law enforcement, those sorts of things that still have a high-end requirement but won't get as big. Now the VMAXe is pretty much a scaled down version of the VMAXe. Now, again, the VMAXe is still a large compute engine in front of the drives. And for the VMAXe, that still holds true. The difference is that this is 4 engines. We top it off at 4 engines. The big VMAXe can go to 8 engines. Still a sophisticated operating system, still API layers to get into the aforementioned operating system. That's what Oracle and VMware and those guys use to get into this device. We then make some scaled down decisions or some simplicity decisions around this device. For example, the VMAXe, for example, always comes with virtual provisioning. This is standard on VMAXe. Virtual provisioning is the ability to provision logically. So in other words, what you do is you generally end up with about 3 virtual provisioning groups, generally flash, usually fiber, and always SATA. What you do is you put 32 drives in here. This might be 5 or 6. And you stripe across these drives. So if you write something to the flash, you stripe it across all these drives. If you write something down here on the SATA, you stripe it across the drives. When you add to these pools, if you make that 64, we restripe across all the drives and we tune that. The purpose of virtual provisioning is to save clicks and save costs. And again, in the VMAXe, this is a cost-saving design. So this is how it works. You don't have a choice here. You do implement this. And then you come over here and you have your applications. For example, your production Oracle is really important. And maybe you have, it's not something that's not, maybe you have mail that you don't consider as important. Some people consider that up here. And then down here, you might have test and dev. And then in here, and by the way, that can go out to 256. That can go to 256. And then you have your policy in the middle, which, for example, for the platinum, or for the high one, you might say, well, I want 20% in the flash, 20% in the fiber, and 60% down here in the SATA. Then you might have a gold for these guys that might go 10, 40, 50. And then you might have a dev, and these guys are just going to be 100% on the SATA drives. What this gives you is a couple of different scalings. For example, from cost, it goes expensive, medium, cheap. From speed, it goes slow, medium, fast. What this does is that it tunes your application in real time across these media types, and we do it every 30 seconds. This is standard on a VMAXe. So while it's a fairly sophisticated piece of technology. From a user point of view, it makes it easier for them. So we ship that standard. So again, we're going to save them, Click's going to save them cost. We do some other things in the VMAXe to make this a little simpler, make it cheaper to manufacture, and contain your costs. For example, drive types on the VMAXe. This is not technical decisions, these are business decisions. For example, flash, it's only 200 gigabytes. On the big VMAX, you can get a 400 gigabyte drive. Fiber drives is only 450 or 600 gigabytes. Okay, we're just limiting the choices. We're going to make this easy for us to manage and assemble. We're going to push some cost out and pass that on. And then the SATA drive is only the 2 terabyte drive. Now on the big VMAX, we have a 1 terabyte up. We have a number of fiber drives, and we have a 400 gigabyte flash for the big VMAX. So for this one, we restrict the drives. Power, single phase. Because this may go into colos, and we're gonna make your power simpler and cheaper. It's also a single floor tile, so it's smaller. It doesn't scale out like the big VMAX does, where we can put 2,400 drives in it. Single phase power, single tile. Now for replication, because remember it's still high end, we actually have something called a Recoverpoint Splitter. Recoverpoint is a piece of technology that replicates the array, and what it does is that within the array there's a splitter, so when you do an I/O, it splits it, and part of it goes into the array itself, but the Recoverpoint Splitter grabs a copy, sends it over to this other array, and it then copies that. So it's something called a Recoverpoint Splitter. We also have on Recoverpoint, one of the differences between Recoverpoint and SRDF is Recoverpoint offers something called continuous data protection. So because you have this continuous streaming of data going back and forth with Recoverpoint, you can say, I've corrupted the data, the application, or maybe one of the humans made a mistake, I want to roll this back 10 minutes. And you can do that because it has something called continuous data protection. So the VMAXe is still VMAX, still has a big compute engine. It's 4 blades instead of 8, so we cut that back. Some of the function we reduced out of the OS, not a lot. API layer is still there. It ships with virtual provisioning every time. So that part, it gets shipped with. That's not a choice. You're going to use pools of drives. Again, the assumption is if it's smaller, you don't have technicians who figure out stripes and RAID groups and metal-uns and all the rest of it. Fast VP is an option, and that's the rest of this picture. I would recommend it because this makes it simple, and it makes it fast, it makes it cost effective. We restrict the drive types, have up to 960 drives. Okay, that's it, that's as big as it gets. We restrict the flash 200 gigabytes of fiber, 450 or 600 gigabytes, SATA goes to 2 terabytes. Single phase power, because again, we're assuming it might be in a colo, single floor tile. We're going to compress the footprint because it's probably going to get a little tight. The replication is something called a Recoverpoint Splitter, where we use Recoverpoint, which pretty much splits the IOs and writes it to the second destination. And that has, Recoverpoint features something called continuous data protection, which lets you roll the data back if you have to. So again, pretty much the same design as the VMAX. We scale it back, cut some costs, make it simpler, restrict some of the drive types, and by doing that, we give you a smaller high-end device for the smaller critical applications. We see these mostly in, like I said, in hospitals, law enforcement, smaller financial institutions typically. One other thing to consider before we go, VMAXe is not upgradable to the bigger VMAX. So if you run out of room on a VMAXe, you'd have to get another VMAXe. So again, what you want to consider is, are you going to surpass these numbers? And if you think you are, then you use a bigger VMAX and you'd use the big VMAX and just buy a subset of the engines and the drives. If you think that that's going to hold you, then you can use a VMAXe, and that'll be your solution.